All right, hello everyone. It's April 17th. All right, so I got it. I got this thing. Hopefully, we'll have some fun. All right, we'll have some fun today. Have some fun. All right, I got a very cheap, very cheap pen, and hopefully this will work. I mean, I think it. If I write slowly, it does work, right? Hopefully I can explain my thought process better. I can draw, let's say, a graph, right? Now, the thing is, it's not the most responsive, so I think I still need to take a little while for me to fully, get accustomed to it. And also the handwriting is terrible. Look at this. That's not my handwriting. My handwriting is better than this. But I don't know. It feels weird. It feels weird. Yeah, my handwriting is definitely better than this. But anyway, and I actually don't know how I can, if I want to cancel, I have to really just. Oh, hold on. I just saw an option. Hold on, let me see. Oh. Wait, I only can do the ones? I'm still learning how this whole thing goes. Wait, maybe it's because I was here. I don't know. I was trying to recreate that delete thing, but it just didn't show up. Yeah, it showed up once and then disappeared. So I think to delete, we just have to erase everything. It's okay. I mean, it's fine. Okay, so that's that. We'll see how well I can manage this. All right, let's finish this first, and then I have some thoughts on this. I think I got myself into a bad shape yesterday, so I'm trying to get out of it. But anyway, let's do this one. Merge strings. Alternately, you're given two strings, well one and well two. Merge the strings by adding letters in alternating orders, starting from word one. If the string is longer than the other, append the additional letters onto the. Oh, it's just this is just a merge sort. Okay, so it can actually, yeah. Let me try easy problem so I can say, all right, I need to first do this. Word one, word two, right? So we have A, B, C. Oh my god, that's terrible. And then Q, P, Q, R, right? P, Q, R. And then we can have an I pointing here, a J pointing here, right? So we're going to start with I and J both equal to 0. And we know I goes first, right? So we'll do A, and I will move on, and then we do J, right? And then J move on, and then we do 8 again, and then we do J again. We keep doing this, one of them will finish first. Now, how do we know which one shall go first? Well, because it does say we want word 1 first, so maybe I should not do, maybe this is not right, right? Maybe I should do I equals 0 and J equals -1, right? And then the condition is if, right, we say I is larger than J, right, then we do word 1 I, right, and then we say I plus equal 1, and else darker pen, hold on, I might be able to get a darker pen. Let's get a darker color. How about this? Yeah. You know what? Maybe it'll be better if I use this. I'm not sure. This looks very thick. Man, it's tough. I'm still working on how to use this. No, I use this, right? I plus equal 1. That's not plus equal to. Plus equal 1, right? Else, which means I is equal to j, right? When that happens, then we will do word to j, right? Because j catches up. No, that's not right. That's not right. Let's do this again. It's actually not that bad. It's not that bad. No, I think they should start the same. Okay. This is actually fun. All right, let's say I equals j equals 0, right? And then we say if I is equal to j. When that happens, we will do word 1. I have to write really slow, otherwise it just doesn't work very well. Right, we do that, and I will plus equal to 1. Right, now I is in front of j. So the next round we can have else. When I is in front of j, we will do whatever we need to do with word to j. Right, and when we've done that, j will plus equal 1. Now j catches up to 1, and next round we do this. Yeah, that will work. Man, it's interesting doing it this way. All right, now we can code. Yeah, I think it'll take me a while to get used to this pen thing, but I think I like it. All right, so we do what we set to do, right? And then, well, we need a result. So result will be this, and then we say while I smaller than len. Actually, let's do this way. Mn is len word 1, right? Len word 2, and this shall smaller than m, and j smaller than n. Right, we say if I is equal to j, then rest.append word 1 I, and then we'll I plus equal 1, else rest.append word 2 j, and then j plus equal 1. Once we get out, only 100. Maybe it'll be easier we just do this way. Yeah, let's just do this way. I think string in Python is very fast, so really, I did not know. Oh yeah, show me. And then we say if I is smaller than m, then rest plus equal to word 1 I to the end, and if I is smaller than n, rest plus equal to word 2 j to the end, and now I'll return rest. That shall do. Wait, that's not right. What the hell? I add an R. Huh? What the? Hold on, this one's right. This one, the first one is wrong. APBQC. Wait a minute, what happened? I do APBQC, right? And then I did C. And wait, I think this is not right? If they're the same, okay, I do this, and this go forward. Oh, that's right, and I get J go forward. And at the end, we do I go forward, so I exit. and I already larger than, so they're both at this position, right? I plus equal 1, right? I equal to j equal to 2, so I plus equal 1 coming out, and I, oh, this is j. Lord, my bad. That's j. Yep, that should do. Okay, so this one is done. It's what we call this. Call this merge sort-ish, right? Merge sort-ish. Similar logic to merge sort. M plus M. Okay, so that's not too bad. Okay, move on. All right, this one. Okay, so now I can try to explain what I was thinking about. Yeah, but this one is not good. I have to go back and forth. But anyway, so what I want eraser, and I want to erase everything. Yeah, I gotta find out a way to delete this as fast as I can. This is not gonna work if I have to do this every time. Okay, so we already identified that each value, if it contains a square, right? Yeah, we will. Okay, 3, 4, 4, 5. I would just actually no. I have this test case 5, 6, 4, 3, 4. Okay, so I have this test case 5, 6, 3, 4, 4, 3, 4. Damn, 4, 3, 4. Right. So we'll turn each thing into a counter by factoring it. So for the first one, we turn into a counter would just be this. Right? That's the first one. This is a 1. The second one will be 2. I have 1 count. Oh, thank you. 3 will be 1 count. Right? And then next one is 2. We have 2 counts. The next one is 3. We have 1 count. And the last one is 2. We have 2 counts. Right? So we turn the original list into this. Now, because we want to find all the subsets that do not contain any counts, that has more than 1. So like anything like this, we can remove immediately, right? So this is what we have, right? This one, and this one. Now, what I'm thinking is we can find all the subsets, right? All the subsets that ending at ending at the curve index. So we start from here. All the subsets that including this one, right, and ending at this one. Now it doesn't have to end, just including, right, including this one, then that will be 1 because this just by itself, right, that's 1. And we say everything that's including this, but now I have 2 and 3, so I actually need to go search everything on the left to find all the elements that do not contain 2 or 3. Right? If they do not contain 2, not 2 or 3, 2 and 3. If they do not contain 2 and does not contain 3, then that's a good one. So this by itself is 1. And now look in the previous, we have 1. So this is 1 plus 1, right? If I here, that's a 2 here. This is already eliminated. So now we look at this one, right? This one, we have 3. So we need to look in the previous that does not have 3. So this one has 3, so this cannot go. So we only have the first one. So this is also 1 plus 1. And then in total, I say it's 1 plus 2 plus 2 equals 5. Is that right? 5? Yep, that is 5. That is 5. Maybe that is the way. Well, of course, if you have multiple in the front, right? Let's say we have, yeah, it doesn't matter. We have something, 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 and then we have, let's say 2, all right, and then something, something. Now we say we want to find everything that including this up to this position, right? Now we need to find, let's say we have 3 of them. 3 of them do not contain a factor 2, right? And then what we're saying is any combination of these 3 will work, right? Which means we have C 3 choose 1, right? Plus 3 choose 2, plus 3 choose 3. Like all of these can fit. So this will equal to 2 to the 3rd power minus 1, right? Will be equal to 7, which means we have 7 different ways for everything in the previous multiplied by the current, then they will all work. So it will be 7, and of course plus this one by itself, right? So it will be 8. So that's kind of the basic idea, and that's what I'm trying to, and what I did. Oh, I can move the canvas. Or I don't need to move the canvas. So that's what I'm trying to do, right? This is what I'm trying to do. So we know because the maximum 30, so the primes, that's all the primes we have. Then we have count. So this counts is just this array, right? This is the array. And yeah, this is not working. This is not working. Just delete everything. Let's redo it. All right. Let's redo it. Actually print the counts, right? We can take a look what the counts look like. Yeah, 5 1, 2 1 3 1, 2 2 3 1, and 2 2. That's exactly the same as this. And then what I can do actually is, maybe I need to remove, right? I need to remove this, the 2 2, all the things that contain doubles. So maybe it will be easier if we start like this, right? Let's say for any nums, and we say f factored, self.factor n primes, right? And then we say if any of the v for v in f dot values, right? Well, check the value if it's larger than 2, larger than 1. If any of the value larger than 1, then we will continue. Otherwise, we'll say, yeah, maybe it will be easier just say if not, then we do counts.append f, right? When we do this, the counts will eliminate, or the 4, right? The 2 counts eliminated. Now everything is actually just 1, right? It's just 1 prime numbers. And then we want to count, so I need a result, right? I have a result. Then I say we can do for I count in enumerate counts, right? So we go 1 by 1, and for each one, we'll add it by itself, that's for sure, and we want to find to the previous, right? To the previous, how many counts in the previous, how many values in the previous does not contain any of the factor of the current. So we should say for j in range all the way to I, do not include I, right? And then we need to say for, oh my god, for key in count.keys, right? We can say counts j is the previous, the count, and we say key is in this, right? So we say if any, right, any of this is true, any key in the current count exists in some previous count. If that's the case, then we don't do it. Oh, actually, we need to count, right? The number of I'll call n equal to 0, right? So if this, then count will plus equal to 0. Otherwise, which means if not, right? So previous count doesn't contain anything. It doesn't contain anything. If not this, you know what? We can have a better logic. All of this is k not in, right? How about this? Again, here it's the same. Actually, I don't like it. I just say all of them, v is equal to 1. Yeah, to not use not, getting the logic a little bit more fuzzy. We should use all, right? We say for all the keys in a count, the key, like this key, this prime number is not in the previous one. If that's the case, then we say n plus equal 1. And you know what? we can do this in one line, but no, let's not do it that way. Okay, so now we have all the n's, and then we can say the total number, right? Rest, so plus equal to, well, actually equal to rest plus what? N, 2 to the n, right? We did 2 to the n, right? 2 to the n minus 1. 2 to the n minus 1. That is the total number. And then plus 1. 1 is just the current value by itself. And we have minus 1 plus 1, so they cancel. So it's just plus 2 to the n. Really? Plus 2 to the n? Huh. Okay, and then we'll mod. Right, and then at the end, we will return res. Is that right? This one's right. Let's try the other ones. Hold on, this one doesn't feel right. You can't just... Okay, so it's not all right. Huh, but this is not working. I think I might be overcounting stuff. I don't know. I need a new test case. Come on, give me a new test case. Give me a new test case. Oh, no. I need to change this. Yeah, this is wrong. Whatever this is, it's ridiculous. Okay, so that's wrong. Man, I thought this is an easy problem, huh? Sometimes question number 3 is harder than question number 4. Expect is 35. Okay, 35. Why am I giving me 77? Jeez, man. Okay, one step at a time. Let's first check counts. Right, is that right? So 5, 6, 3, 5, 6, 7, and 7. Okay. And then we can check, let me check the n at every time. Right, let's check the m, I, and n. Right, 0, 0, 6 is 1. And then 3, right, that's 1. You know what, that'll be easier. Let's just do counts. I count. Right, 3 should be 1. Because that's only 5. And this 5, right, this 5, where is this 5? This is 5. Shall have 1 and 2. Yeah, 5 have 2. It does not have this one. And this shall have 2. And this shall have 5. 1, 2. Oh, this is not 5. Oh, that's why it's hard. Yeah, I was thinking about this last night during sleep. I was like, yeah, isn't this so straightforward? No, it's not. The issue is when you do this, you have this counter, right? You have 2 and 3, and you have 3 again. And you have 2 and 3 again, so they cannot all be included. Oh, Lord. What do you think? Well, so I'm at 7. Right. I am at 7. Right. And I have previously 2, 3. Okay, so we can do that. And then previous 5, we can do that. And then we have a 3. But 3, we have already 2, 3. So we cannot do the 3 again. I have 2, 3. Maybe I can say how many of the previous have. Now, we're looking at this, right? I'm at here, I'm looking at counter 2, 3, right? So I can say how many, what I'm thinking, how many non-square free that ends in 2, 3, ends in the 6, right? Okay, I can do that. And then I do 5, and I say how many is ending in that. And then I do, what would that be the case? We just add them together? Maybe? If you think about it, right? If you think about it, I want to know all the previous, right? There are ones that I can include and there are ones I cannot include. And then we say the ones that I can include. But no, the ones I can include, they may include the things I cannot include. Indeed. This is, I still have issues. Or maybe we can say, I find the previous, right? I find all of them. Can I obtain the total number of squared among them? If I can get a total number of squared among them, then I can minus that value. But how do you get the total number of squared among them? Or you can say, I'm currently 7, right? Which means any of the previous value does not contain 7, I can include. But I also need that to be a single. Everything that's containing this, right? So I shall be able to get this 1, right? Every single thing by itself. And right, we know ending at this, right, I have the total number of square free, right? So I have a total number of square free for each one ending at this. That should be good enough, right? That should be good enough because they can all fit with the current one. But now the trouble is when we have the square free, like a 2, 3, if I have this 7 in front, right, then 7 will be included in this one, but it cannot be included in this one. Then what do we do? Still no good. All right, I'm gonna check the hints. DP, bit manipulation. Okay. What's in there? Are 10 primes before number 10. That is true. Okay, hint 2. Label primes. Huh. No. No. Oh. Oh, using that primes. Okay, denote the number and let dpi and the mask denote the number of subsets before index I with the subset of taken primes. Oh my god. Oh. So, what we're saying is dpi mask is the total number of subsets up into I with the mask is these has been taken. Okay, so now when you go for the next one, right, I have everything at the next one, then I need to go to each one of them. All right, go to each one of them. So we go to the previous one, but there will be lots of masks. There'll be lots of masks, but only 10. What's 2 to the 10? How many masks can they be? 2 to the 10, 32, right? No, 10, 24. You have 10, 24. So you go to the dpi, I minus 1, right? They'll have all the masks that it has. Then go through all their masks and then try for you. If you can fit in, then they will work for you. And you go to the previous one and go through all the masks. Go to the previous one and go through all the masks. Let's see, check the last one. Have a common prime, then it is impossible to, yeah, otherwise it is possible. How would you check that? How would you check that if you have a mask and you have another mask? You can hold on. So basically what you're saying is, let's change this thing. Oh my god. Huh? It just deleted by itself. Man, this is a terrible app. Okay, so let's see this 5. All right, we have 5, 6, 3, 5, 6, 3, 5, 6, 7, and 7, right? So instead of a counter, we will do, so we have a bit mask, right? So let's say this is 2, 3, 5, 7, oh, it's going 9, 11, right? That should be enough because we don't have that many. So I actually only need 4 positions. So the first one we can record as 0, 0, 1, 0. The second one is 1, 1, 0, 0. The third one is 0, 1, 0, 0. Next is 5. Next is 6, 1, 1, 0, 0. Next is 7, 0, 0, 0, 1, and 0, 0, 0, 1. Right? Then we say dp I and mask is the total number of square free up into I with the current state. Like when all of them put it together, it's mask. So if we go for the first one, well, the first one actually is just by itself, right? It's just by itself. 0, 0, 1, 0. So that's the mask, right? So how do you want to do it? We can say 0, and then this would be mask. Damn, how am I gonna put mask there? So 0, 0, 1, 0, right? That's the first one, so that's 1. And all the others are zeros. We probably can use default dict for this, right? Now we have 1. Okay, now we're looking at this one. So this one, we look at the previous and go through all the masks they have. So the previous, all the mask is this, and then we say this. And how do we see that there's no overlap? I mean, what we can do is and this mask and the current one. We AND the two. If there is no overlap, then if we AND, the result shall be 0. Then we AND, and the result is 0. So we say for here, actually this shouldn't be here. I need to do let's say 0, 0, 1, 0 is 1. Yeah, it's not a, it's, hold on. It's not a matrix. 0, 0, 1, 0, that's 1. Okay, now index 1, the first is we do this or this, right? That'd be 1, 1, 1, 0. That's 1. And 1, 1, 0, 0. That's 1. And then at position 2, we look previous. All right, so we look to position 1, and then we try to AND these two. Now this and this cannot work because I have a 1 in this position, and I have a 1 in this position. Cannot work. Yeah, because that's 3, and that's a 6. So basically, position 1 doesn't work. But we go to position 0, that works, because position 0 we have 0, 1, 1, 0, right? That gives us 1, and of course itself is a 1. Now index 3, we have this one. Again, we go to index 2. 0, 0, 1, 0 doesn't work. 0, 0, this one does work. So that's 0, 1, 1, 0. That'll give us 1. Right? And then we'll go to this. 1, 1, 1, 0 doesn't work. 1, 1, 0, 0 works. So we have 1, 1, 1, 0. That's 1. Then we go to position 0. Doesn't work. And also it has itself 0, 0, 1, 0. So that is 1. Now position 4, index 4. Okay. Index 4 is this one. So this, look to index 3. 1, 1 doesn't work. 1, 1 doesn't work. This one does. So we have 1, 1, 1, 0. That's, we have 1. Position 2, 1, 1 doesn't work. 1, 1 doesn't work. Position doesn't work. Position 1 doesn't work. Position 0, it works. We have 1, 1, 1, 0. Oh, both are 1, 1, 1, 0. Yeah, exactly. So we can actually update. This is 2, right? So we don't need this one. And of course, record itself. All right, position 5. Now this one's interesting. Now this is position 5. 5, we can, 5 basically we can do any of them, right? So we have 1, 1, 0, 1. That would be 1. 1, 1, 1, 1. That will be 2. Right? And then 1, 0, 0, 1, 1. That's 1 that we're looking at here. And then 1, 1, 1, 1 again. So this is not 2. This becomes 3. And then we have 0, 1, 1, 1. That is 1. And this 0, 1, 0, 1. That is 1. and 0, 1, 1, 1. Now we have this one already, so that's 2. 1, 1, 0, 1. We have this already, 1, 1, 0, 1. 1, 1, 1, 1. So 1, 1, 1 now become 4. And then 0, 0, 1, 1. Wait, this one becomes 2. Okay, so that's the 5. And then the last one, position 6. Yeah, position 6, we cannot hit any of this, but we can hit any of the previous one. So basically just a copy of the previous one we have. This is 2, this is 4, 0, 0, 1, 1 is 2, 0, 1, 1, 1 is 2, 0, 1, 0, 1 is 1. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. So we have 11 so far. And this is 2. So that's 6, that's 10. That's 10. So add it together, 31. But the answer is not 31. Did I miss? Yeah, well, you missed the 0, 0, 0, 1. Yeah, you missed this. And you missed 0, 0, 0, 1. And that's not 10. We have the 10, 11, 12. So this is 12. This is 12. So 24 is 35. 35. And the answer is 35. Oh, I did not think about this. Wow, this is such a good method. How'd you come up with this? Well, you come up with this because you wanted the DP, and then we had issue to do DP, right? Because the state is unclear, right? That's, yeah, exactly. That's the issue. I wasn't able to put it down into writing, but just the field's not right. Like I don't have a clear state, because yes, yeah, what I was trying to do is I use a counter and I check if it exists, right? But then when you do this, you can only check individual. You cannot check the combination of the previous. That's why this method is wrong. And you can check the previous. If you turn it into a bitmask, holy crap. Lord. All right. Now we need to implement it. What do I do? How do I implement it? I need to turn it into a... Jeez, man. How do I implement it? Okay, so I need to implement it here, right? Instead of a counter, I need to do, this shall be 1. Okay, wait, is it 1 or... No, this shall be a 0. We start with 0. And then, this is fine. And then blah, blah, blah. We can, if this, then I need to left shift, right? We need to left shift. But how do I know if it's already... Okay. Let's do it. So we can say, we need to check if that position is already 1, right? That position is already 1. So what we're gonna do is 1 left shift I. Okay, that's what I want to do. 1 left shift I. 1 left shift 0. What's 1 left shift 0? That's 1, right? That's just by itself. So what we need to check is if res and 1 left shift I, if it's true, that means at primes I has already been there. In that case, let's return -1. Okay, it's bad. Otherwise, we say res equal to or equal to 1 left shift I. We still need to divide I into plus equal 1, blah blah, and then we'll return. Okay, so we'll do this. Bitmask equals this, and then we say if bitmask is larger or equal to 0, then masks. Okay, we can say masks dot append bitmask. All right, let's take a look, see if this is correct. It's not gonna count. We don't have counts anymore. M for m in masks. Let's do binary m, 2 to the end. All right, is that right? Well, it's the other way around. Oh my god. Yeah, so I put 2 at the front. So the first one is, what's the first one? 5. So that should be 2, 3, 5, right? 2, 3, 5. And this is 2, 3. Yeah, because just to the rightmost is 2, 3. That will be 3. This will be 5. This will be 6. So we already delete 4, 7, and 7. Good. That is good. Okay. And then we need a DP. All right. DP, what does the DP look like? DP will be a list, and each one is default dict. Okay, so it's going to be a, do we have a default dict? We do not. I don't need counter anymore. Default dict. So it shall be a default dict int. All right, for this in range. No, not range. For this in masks. Okay. We'll call it masks. I'm gonna change its name. I don't like to call it masks. Well, I guess it's fine. Doesn't matter. Okay, now we need to go from the first mask all the way to the end. All right. Then we say for I, right? I don't like to call it mask. Represents RPRs represent rep in enumerate represents. Okay, for each one DPI rep, right? DPI rep will plus equal 1. What, that's by itself. And then for j in range all the way to I, and within j for mask in dpj. So dpj is the default dict, right? The default dict. So dot keys, right? Those are the keys. Then we say if mask and the rep, if not, then dpi mask or rep plus equal 1, right? If it's equal to, if it's not equal to 0, that means we have overlap. Then we do this for everybody. Once we're done, we can have a result. Right, we can put the result here. Res plus equal to dpi dot values, and we'll sum it. Equals res plus this and mod. right? And then we'll return rest at the end. Okay, let's try this one. Counter, where? I have counter, where? Psh, that's int. Oh, what? I count 35. Dude. Oh, this is not helping. Jesus. Okay. Yeah, right, 1 1 1 1 1 1 1 1 1 1 1. Yeah, that's correct. And I have 1 2. I have 1 2, and then 2 4 2 2 1 1. 2 4 2 2 1 1. 2. Ooh, there's no 4. 2 2 1 1. Interesting. Where did I got it wrong? 1 2 3 4 5 6. 1 2 3 4 5 6. Right? I have 3 2. I have 3 2 2 1 and a 4. Which one is 4? 1 1 1 1 is 4. Because I have here, here, and here. Right? 7. Right, that's basically 7. I have 7 here, here, here. So 2, 3, 4. 15 shall be 4. That's strange. Oh, it's not plus equal to 1. Dude, it's not plus equal to 1. J. Mask. There we go. Yeah. Okay, let's try everybody then. Nice. Okay. Let's try. Please don't time out. Oh, it's timing out. Oh, Lord. Okay. 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 So with the hint, we're timing out. Yeah, because we have so many for loops here. That's already, it doesn't look good, right? We have, because this one can be very large. So we need to make this one shorter. How do we make it shorter? Well, I mean, we go through everything, right? What if we keep track of all the state that has occurred so far? Okay. All the state that has occurred so far. Then we can go through that. But that thing is not huge. That thing is not huge. Yeah. So this DP needs to change. I think I was misled by this. So instead of recording every single one, I could just record this entire thing, right? Because like we have 110, we have 110. I can just call them as 2, right? I don't have to, which means this DP can just be a default dict and int. And then for I and this, I say dp rep plus equal 1. And then we will go through, actually let's go through the ones that does not have rep first. So we can say for, right, mask value in dp dot items. Okay, and yeah, I like to do this one at the end. Let's do this one at the end. Right, and we say if not mask, right? Well, then we say dp this will plus equal to dp mask. And then at the end, this will plus equal 1. Now I don't need to do this. All I need to do is at the end, we just return some what? dp dot values. How about this? Dictionary change size. Oh. Yeah, you're right. You're right. Well, all we care about is so let's just do the. That's why you don't use I see. Times 10225. It's 25. That shall do. Yeah, but you know, and then we have to go through 1,000, but that's okay. Then we shall just do, right, for, oh my god, mask in range len dp, right? And then this will plus equal 1. And then we'll just sum this thing. Out of range? Wait, which one out of range? 1026. How is that possible? 1026. What's mask and what's 1026? What's 1026? 1, 2, that's more than 10. Huh? What? What is this? What is this nonsense? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How do we have an 11? That's a mask. That should be 1025, right? Wait, what's mask? 1024. Oh, we don't have 1024. My bad. Yep, that shall right. That shall be right. Okay. Well, if that's the case, then let's just put this one inside, because I don't really need it on the outside. But then you have to create every single time, and that's wasteful. Okay. This one shall be right. This one shall be right. Now I understand what dp stands for, right? All right, let's try this one. What happened? What? type error. Oh. You need to, oh my god, I need to, I hate this. I do not like this. I forgot the mod. A mod. Don't like this at all. Yep. Alright, this one should be right. Lordy. What a journey on this one. Oh yeah, it's pretty tough. It's pretty tough. I mean, this is just, this thing, the hint, one of the hints, this is misleading me. This is misleading me. You don't have to do it this way. The DP is just a 1D array. It misleads me. But still, I didn't think about using bitmask. That was tough. This is hard. Come on, this is hard. Let's add this to the nightmare. Well, I mean, how should I say? The trick, right? This is the trick to use bitmask. I think if we can figure out this bitmask thing, the rest is not that hard. Well, probably hit the TLE because we didn't realize we can simplify the DP itself. But the bitmask, man, that requires some ingenuity, right? Bitmask. Because you want to do DP. Yeah, problem like this, you think it's gonna be DP, but then you're like, but we don't have a state, because DP requires state, and it's very difficult to get a state of all the value like multiplied together. How do you get a state? So you want to know, like saying, which prime factor, which prime numbers has been included in a product. Yeah, you have to, if you think this way, and then you also know each prime number. Now I think the hint is each prime number occurs only once. So it's a kind of a binary, right? For each prime number, it's a binary. Either they exist or they do not exist. And you need something to represent the state of the product of some numbers, which is these prime numbers put together. And each one can only occur once. Yeah, so I can see you might be able to bridge from this idea to bitmask. But still, it's a jump. It's a jump. All right. Yeah, that will be it for today. All right. So, how do I get the setup? Well, how are we gonna do this? But anyway, I need to write something here. So the most important trick is yeah, you can send me the link. I'll join after I finish. The most important trick, what's the most is the bitmask, right? But to get there does require some ingenuity. All I can say is I was having trouble getting DP to work because it is difficult to figure out the state, right? and the state shall be the product, right, of some numbers. And since the product contains only singular prime factors, that is the and the total number of prime factors is only 10. So these are the hints for bitmask. Yeah, once bitmask is acquired, the DP is not that hard, right? Not that hard. But the hint of the problem still is somewhat misleading. 124 times n. Okay, that shall be this. All right, yeah, I'll end it here. I'll see you guys tomorrow then. Adios.